get to sit down on the couch. Home sweet home. Finally, I get to rest a little bit. Who could possibly be calling right now? Oh, it's my brother. Let's see what he wants. Hey, Josh. Yeah. Hey, chill out. It's okay. I promise. Yeah, I know. Liam. My nephew Liam, your son. I know who he is. Yeah, I know his birthday's coming up. You want me to plan his party? There's gonna be 20 people there? Yeah, I can do it. Okay, I'll send you some diagrams for the tables. All right. I'll talk to you later. All right, bye. It's gotta be perfect. It has to be perfect or he'll never forgive me. Who could that be? My brother again. Okay. Hey, what's up? Yeah, actually, it's awesome. I just figured out how exactly. What? Wait, what do you mean? Our sister's not coming to the party? So you're telling me there's not 20 people anymore, but only 19? Oh, no worry. All I'll do is change one. Wait, so you want the same number of people to be at each table still? Okay, I'll try to make it work for 19. Something's not right about 19. What changed from 20 to 19? Something's pretty different here. So the party changed pretty drastically when we went from 20 people to 19 people in terms of planning for the tables. When we had 20 people, we had a lot of different options. So we could do one table of 20, which is like 1 times 20. We could do 20 tables of 1. We could do 2 tables of 10. We could do 10 tables of 2. We could do 4 tables of 5. And we could do 5 tables of 4. So notice here, we had 6 different options of choices. Now, when we went over to 19, it was a little tougher to work with this number because we only could do 1 table of 19 or 19 tables of 1. Notice here there were only 2 options. The reason for this is because the number 19 is much different than the number 20. The number 19 is a number that we call a prime number. Now, a prime number is a number that has exactly 2 factors. And when you're thinking about what factors are these. So 1 and 19 are the factors of 19. Now, every prime number always has 2 factors, 1 and itself. So we'll write that here. So 1 and itself. There we go. Now, a composite number is kind of the opposite of that. A composite number has more than 2 factors. So a composite number has 3 or more factors. So a composite number factors would be 1 itself plus something else. So it has a factor 1 itself and something else. So the number 19 is prime because the only 2 factors of 19 were 19 and 1. The number 20 is composite because it has many factors. It has 1, 2, 3, 4, 5, 6 different factors. So thinking about prime numbers and composite numbers, if we're trying to figure out a number that would be like 19 or another prime number, we could come up with a few. 11 would be prime, 13 would be prime, 17 would be prime. If we're trying to come up with another composite number, number that would be like 20, we could say 12, we could say 6, we could say 15. So other numbers that have more factors besides 1 and themselves. So one thing to do when you're focusing on finding prime and composite numbers is thinking about the prime numbers 2, 3, 5, and 7. The first way to find composite numbers is to go through and find the multiples of 2. So to find the multiples of 2, you're thinking of all of the numbers that are even. So if I go through this chart, I can just go straight down through here, and I can say that every even number is a composite number except for the number 2. Every other even number is going to be a composite number, as you can see here. Now, we then go through, except for 2, which is going to be a prime. We then go through the 3s, and we say that every multiple of 3 is going to be a composite number. So that would be 6, 9, 12, 15, 18, 21, and so on. We could start looking for the multiples of 3. We then go through the multiples of 5. The multiples of 5 are going to be every number in this middle row here, and then every number that ends in a 0 as well. And then lastly, we go through the multiples of 7. Now, most of the multiples of 7 are already covered by the 2s, 3s, and 5s. For example, besides 7, which is prime, 14 will already be covered. 21 is already covered because it's a multiple of 3. 28 is an even number. So if we go through and look for the 2s, the 3s, the 5s, and the 7s, we actually can find every composite number between 1 and 100. And then all of the numbers left over are prime numbers. So this is a strategy that really helps as you're looking for all of the prime and composite numbers between 1 and 100.
Are you seriously telling them another math story? For once, can't you tell them a story that doesn't involve math?
Nah. Math stories are kind of my thing.